negative 2. And do you remember what we do to start problem 1? Yeah, we add 1 to both sides. We get 2 sine of theta is equal to negative 1. We divide by 2, and we get sine of theta is negative 1/2. How do we determine where it's positive and negative? All students take calculus, so therefore it's going to be negative in which quadrants? 3 and 4.
All of them are positive, sine is positive, tangent is positive, cosine is positive. All students take it. How'd you pass that test?
You remember that? All of them are positive here, sine's positive there, tang's positive here, and cosine's positive here.
Okay.
You got like 100% on that.
How I remember it,
like
sine is the y value. Exactly, that's how I remember. Sine is
tangent
what?
is like slope.
Exactly, that's yeah.
It's the same thing? Okay.
Sneezers, got it. Okay. So we got 30 here, and we got 30 here. So we got theta is equal to 210 and 330. You guys kind of remember that process?
Yeah.
Okay, Max doesn't because he was gone. Number 3, we're going to move to, and here we're just going to start by subtracting that 5. And I get negative 6 tangent of theta is equal to negative 8. I divide by negative 6. I get tangent of theta is equal to 4/3. So which quadrant am I working in? The first and the third. Yep, tangent is positive, first and third. I inverse 4/3 on my calculator, and if you inverse 4/3 for tangent, you get 53.13 degrees. So you got 53.13, and you got 233.13.
Wait, can you remind me how you got that again, the 53 point?
So on my calculator, I'm going to press tangent inverse, so second tangent, and I'm going to type in 4/3. And it'll spit that out. Just make sure you're in degrees and not radians. Okay. Let's move to number 7. I'm going to subtract 1 from both sides, and I get 3 secant squared of theta is equal to 12. Divide by 3 secant squared of theta is equal to 4. Now what do you want to do? Let's square root both sides. And I get secant of theta is equal to plus or minus 2. I'm going to have 2 options there. I don't have a secant button on my calculator. I'll flip it to cosine, and if I flip it to cosine, that means that this is going to be plus or minus 1/2. I cosine inverse 1/2. What's the cosine inverse of 1/2? 60. Notice it's plus or minus. Cosine is positive in the first and the fourth. It's negative in the third and the second. I've got these 60-degree angles floating around here. I'm going to have 4 solutions. So theta is equal to 60 and to 120 and to 240 and to 300.
Did we do these notes when we were supposed to do it? Is this like a review? Okay.
I'm just skipping around a couple problems, bring your mind back, because we want to go to harder problems today. So we're just going to set up the next 2, and then we're going to go to our tougher problems. Anybody remember what we would do for number 9?
Factor.
We do factor. Good job. So we've got a 5 cosine of theta and a cosine of theta. And now there's a 4 on the end, so it's either going to be 2 and 2, or 1 and 4, or 4 and 1. Anybody know?
4 and 1.
Yep, it's going to be 4 and 1. And so I set up 2 equations then. I have 5 cosine of theta plus 4 is equal to 0. And I have cosine of theta plus 1 is equal to 0. Can everybody agree that we know how to solve that? Can we just skip solving that and go to the next piece here? Cosine of theta is equal to -1. Talk to the person next to you. Don't use your calculator. Can you figure out where cosine is equal to -1? Talk. Where is it equal to -1? Go.
Yeah.
The x value is equal to -1 at 180 degrees. And so that's that solution. You'd get 2 more over there. I think you guys know how to do that. We don't need to spend that time. Do you know what you would do for number 10? Similar to the last one.
Factor out the sine.
Factor out the sine. You'd get sine of theta times tangent of theta minus the root of 3. And then you could solve both of those. So that should bring back a little bit of memory on how we solve these pieces. So let's flip it over and focus on this type of equation. What's different about this equation, we want to get to the slightly harder ones today, is that you have a number in front of theta. And that's going to change the way we operate. It's not going to change the way we start it. We're simply going to subtract 2 from both sides. And we get 4 sine of 2/3 theta is equal to -2. We divide by 4 to get sine of 2/3 theta is equal to -1/2. And now you can see that in order to solve for theta, we need to move both sine and we need to move 2/3. What do you think we have to get rid of first, the sine or the 2/3?
Sine.
Gotta get rid of sine because it's sine of that 2/3 theta. And I'll only write this down once. You don't have to write it down, but I just want you to understand algebraically what the heck is happening. What we're going to do is we're going to get rid of sine by doing sine inverse. That makes those go away. And then this side you do sine inverse as well. So we're going to be left with a 2/3 theta equals whatever comes up when we do our quadrants. Okay? So if I sine inverse both sides, I get 2/3 theta is equal to, and then we'll see what we come up with when we inverse -1/2. Sine is negative in which quadrants?
3 and 4.
3 and 4. We've talked about this multiple times now. Where is sine equal to 1/2? What's my reference angle? 30. And so you can see that the two angles are in fact 210 degrees and 330 degrees. So I don't have theta equals that, I have 2/3 theta equals that. What do I do to solve for theta? Multiply by the reciprocal of 3/2. And so you get theta is equal to 210 times 3 is 630. 630 divided by 2 is 315 degrees. That'll be one solution. And then 3 times 330 is 990 divided by 2 is 495. And there's my two solutions. Now the fact is that as you look at these two solutions, one of them is outside of this 360. You don't have to get rid of it. When it says to solve between 0 and 360, let this be our practice that when we set this up, we'll only look between 0 and 360. Does that make sense? When you set this up, go between 0 and 360. Whatever comes out after that comes out. Okay. All right, next one. We got cosines on both sides. One squared, one isn't. A nice option here is going to be subtract that cosine over. We saw this on the last page a little bit. What do you think you can do to both do here? Factor out the cosine. Good. Whoop! I got to factor out the cosine of 3 theta. Sorry about that. So I have cosine of 3 theta times the quantity 2 cosine of 3 theta minus 1. I'm going to set up two equations. Cosine of 3 theta is equal to 0, and 2 cosine of 3 theta minus 1 equals 0. Talk to the person next to you. Where is cosine equal to 0? Think of the unit circle. Where is cosine equal to 0? Go.
Is there supposed to still be a square in the equation?
No, because cosine times cosine
Oh, yeah,
is
yeah,
cosine
yeah,
squared.
yeah,
See
yeah.
that now?
Yeah, we're good.
Where is cosine equal to 0?
Yeah.
Cosine is equal to 0 when the x value is 0. X value is 0 at 90 and 270. So I have 3 theta is equal to 90 degrees and 270 degrees. I divide by 3 and I get theta is equal to 30 degrees and 90 degrees. I go over to the right side to solve the others. I add 1 and divide by 2. I get cosine of 3 theta is equal to 1/2. So that says cosine is positive 1/2. In which quadrant is cosine positive? First and fourth. Inverse cosine of 1/2, 60. So we get 3 theta is equal to 60 degrees and 300 degrees. We need to divide them by 3 and we get 20 and 100. And those are my solutions. I've got 4 of them. So that's the next step, is to be able to handle when you have a number in front of the angle. Another thing you got to be able to handle is what happens if you have multiple trig functions in the same equation. I wish that there was something that related sine and cosine together.
Tangent.
Tangent. Sine over cosine. Yes.
Back it up.
Sure.
I didn't quite get that last part.
So 3 theta is equal to that. So I divide each one by 3. As Nevaeh said, sine or a tangent is sine divided by cosine. So watch how easy I'm going to make this trig equation. I divide by cosine, I get negative root of 3 is equal to tangent. That one recognition makes the problem pretty simple. In which quadrants is tangent negative?
2 or 4.
2 and 4. If you inverse the root of 3, you do get 60.
So why don't you inverse a negative?
So the tangent inverse of negative root of 3 gives you negative 60 degrees. And I just like to, I say I use up the negative when I determine the quadrants.
Okay.
That's how I do it.
Okay.
You could do it and say negative 60, and
'Cause that would mean
that is
divorce
negative
from the
60.
negative.
But again, we don't want negative 60 as an answer. We want our answer to be between 0 and 360.
Okay.
So I think it's, yeah. Does that make sense?
Yep.
So your answers then are 120 degrees and 300 degrees. Hey, how are cosecant and sine related? They are reciprocals. So let's write this as 1 over the sine of x over 2 is equal to 2 sine of x over 2 over 1. Now at least I have sine. I know it looks really complicated, but I could cross multiply here. 1 times 1 is 1, and sine times sine is sine squared. I've got 3 2's in this problem. I'm going to have to be careful there. I'll divide both sides by 2 to get 1/2 is equal to sine squared of x over 2. Now I square root both sides. Does everybody see that the square root of 1/2 can be rewritten as the root of 2 over 2? And that's positive or negative because we're square rooting the square. And I get sine of x over 2 on that side. So now I have to figure out where is sine equal to the root of 2 over 2. Root of 2 over 2, what spot is that on our unit circle? Yeah, 45 degrees. First, second, third, and fourth quadrant, 45 degrees. Axel, how did it go?
Pretty good.
Are you a rock star when it comes to band?
Sure.
What instrument do you play?
Percussion.
Percussion. All right. I got 45, 135, 225, and 315, but those are not the answers. What am I going to have to do to get the answers? Multiply 2, and I get x is 90 degrees, 270 degrees, 450 degrees, and 630 degrees. This next test, I've said it before, it's not an easy test. And when you solve the trig equations, you know, some of them are easier and some of them are not easy. So spend some time on the assignment, ask the questions, come on in, find me, and I'll help you.
So do you have to wait until like that last step to multiply the 2 that's on the bottom?
Absolutely. Absolutely. And here's the reason why. If you look at it, if I look at this piece right here, okay, if I were to plug something in for x, say I plug 60, you would first divide by 2, then take the sign, and then multiply by 2. So since you did x over 2 as your first thing, that's the last thing that you will undo. See what I'm saying? But it is very common. I'll get this problem on the test, and people say, I want to get rid of the fraction. So I'm going to multiply by 2, and I get 4 sine of just x then. And they're feeling pretty happy. And at that point, I'm saying you're making math up at that point. So. But that's the kind of stuff I see quite a lot. That help? Okay. We flip it over. Only 2 problems. We do 5 and 6. 5's a big conundrum. It's really tough because I've got sine of 2x. And if you notice, this other one's just cosine of x. Gina, can you see that we got a double angle and a single angle?
Yes.
And then we also got 2 different trig functions.
Yeah.
The fact is I've got 2 different trig functions. That I'm not that worried about that. I could deal with that. But the fact I got a double angle and a single angle, doesn't that just make you angry inside?
Yeah.
Don't you wish that there was a formula which we could reduce double angles down to single angles?
Yeah.
Wouldn't it be awesome if we tested on that in chapter 7.1 through 7.3?
There is.
Our double angle formulas?
Yeah.
Who here remembers the double angle formula for sine of 2x?
Be awesome if we remember.
My paper does.
Oh yeah.
When you're doing your double angles, remember sine of 2x is 2 sine of x cosine of x. That's one that's kind of handy to keep in your brain. We use that quite often. So I make a substitution in this situation. Examples of identity substitutions, identify substitutions, identity substitutions. That's a substitution I can make. That's on your sheet. I'll give you that same sheet, but you got to know to use it. I would say that's a good one to keep at the forefront of your brain. Another good one to keep at the forefront of your brain, sine squared plus cosine squared is 1. Yep, don't ever forget that one. Okay. So now the problem's easy. I just factor out a cosine.
Wait, why can you change the sine of 2x to 2 sine of x cosine of x? I should know that, shouldn't I?
I wouldn't say so. Like the whole y thing is pretty involved. I'm going to go to the best answer I can give you right now. Do you remember that sheet of formulas I gave you on the last test?
Uh-huh.
Like huge, like front and back?
Yeah.
That was one of the formulas on there.
Because he said so.
Yeah, let's glance
take
it
a
out.
look at it.
Yeah, there you go. So right here, the double angle formula guy right there.
Mhm.
Yeah, this one says sine of 2a is 2 sine of a cosine of a.
Okay, so it's just the law.
Well, and we proved it one day. We did prove it.
Oh.
But I don't want, because then that proof would require we do this, the sum of difference proof as well. So we'll just skip that part. But so we set up 2 pieces, cosine is equal to 0, and 2 sine of x minus 1 is equal to 0. And you already know where cosine is equal to 0. You already talked about that, didn't you? Cosine is equal to 0 for which 2 values? Where's the x value 0?
92 seconds.
Good, 90 degrees and 270 degrees. And then we add 1 and divide by 2, and we get sine of x is equal to 1/2. And just note that sine is positive in the first and the second quadrants. And if you inverse 1/2 for sine, we get 30 degrees, very good. And so therefore we have 30 degrees and 150 degrees. If you inverse 1/2 for cosine, you get 60. But for sine, you get 30. And if you want to use your calculator in that situation, you sure can as well. Last problem. Gina looks at this one. She's like, yay, I do not have a double angle situation, do I?
Nope.
And I got sine and cosine, which makes me happy because I think of tangent, but I get that 1 in the middle. So sometimes people do this on test and be like, hey, you know what? I want to divide both sides by cosine. And that way I get 1 plus 1 is tangent. And so I got 2 is tangent. Easy to solve, right? Everybody feeling good?
No.
What did I not do? I didn't divide the 1. And notice if you divide the 1, instead of getting a 1, you'd get secant. And that just makes it just as ugly, doesn't it? Shoot. So the whole tangent thing doesn't work here. What other thing do I know that relates sine and cosine together?
Sine squared plus cosine squared equals 1.
Yes, except I don't have a squared.
You're gonna have to add it, or you're gonna have to square it.
You're gonna have to square both sides,
Yeah.
which is a risk that we run. In mathematics, it's like the last thing that we want to do, but it's an option. And here's why. If you have x equal to 3, there's one solution. The answer is 3. If I square both sides, I get x squared is 9. Now how many solutions are there?
2.
There's 2. You just added a solution by squaring things. So we'll have to check our answers in the end to see if they actually work. Okay, so let's do that. Let's square both sides. Last problem. Good thing you guys are smart. If you weren't smart, this class would be hard. Cosine of x plus 1, quantity squared. So I got to FOIL that up. I can see I'm going to get a cosine squared right away. And then what am I going to get?
1.
Close?
Plus 2 cosine.
2 cosine. Gina comes to the rescue.
That's like a rookie mistake.
It's okay. We're all rookies every once in a while. I made a mistake yesterday with the permutations and combinations.
Did you make up for it today?
Yeah, I confessed to second hour, which I thought they'd be rather forgiving. They looked at me like they kind of lost faith or
It
disappointed
was
me.
heavy, wasn't it?
Oh, it's
I feel
Hannah
like
Schumacher.
Emily-
Hannah's the worst. She's Hannah Schumacher. I'm telling you, just unforgiving. You know the type. All right, so I love Hannah. So now I've got a sine squared and I got cosine and cosine. So I want to change this all so that it doesn't have any sine in it. I just want cosine. So what can I substitute for sine squared?
Cosine.
Close. 1 minus
Cosine
cosine squared. Good. So now I have this substitution. 1 minus cosine squared. And I've got cosine squared of x plus 2 cosine of x plus 1 is equal to 1 minus cosine squared of x. Great. Now they all have cosines. Now I feel like I can see a path forward. I subtract a 1 from both sides, and what happens? They be gone. I add the cosine squared, and I get 2 cosine squared of x plus 2 cosine of x is equal to 0. What? I can factor. Tyler's impressed with my Spanish. I factor out the cosine, I get 2 cosine of x times cosine of x plus 1 is 0. I have 2 equations to set up. They're very simple. 2 cosine of x is equal to 0. And then this one will be, obviously, cosine of x is going to be equal to -1. We've answered this question 3 times already. Where is cosine equal to 0? 90 degrees and 270 degrees. And we've answered this once already today. Where is cosine equal to -1? 180. But as Nevaeh said when we square both sides, she said, careful, Mr. Gantz, you're going to add a solution that doesn't actually work. We call it extraneous. I said, thank you, Nevaeh. So
Wait,
in
do we
order
have
to...
to divide by 2?
That's what I was wondering.
Yeah, that's what I just did.
Yeah.
Was 0 divided by 2?
Oh, yeah.
Oh.
Oh, you're so smart.
Good thing he's teaching a class.
All good?
Yeah.
Okay.
I wrote it as 1/2. And then I saw he didn't write it, so I erased
You wrote-
it.
You wrote what half?
Yeah. I
That's
was
all
thinking there was a 1 there.
Yesterday I had a student call Mankato Mankota.
Wait, who was it?
I'm not saying.
Oh.
They were talking about that one state south, they're like Mankota. I don't know what it's called. I've never been there.
He's never been there.
Meg, Mankato? Is that what it's called? It's called a Mankato. There's another student, like, what do you think the average population of a state is in the United States? Like, I don't know, like 4,000? And the other was like, what? That's dumb. Like, there's way more than 4,000. Like, just think about Minnesota. We got like St. Paul, Minneapolis, Mankato. I'm like, oh my gosh.
It just kept getting worse.
Where am I? Like, stop making crap up. Jeez. Oh, Mankato. Oh, all right. So, as Nevaeh said, to finish off this problem, we must plug in our results to see if they work. What is the cosine of 90? 0 plus 1. What's the sine of 90? 1. So 90 works. Welcome to the party, 90 degrees. We move on to 270. What's the cosine of 270? What's the sine of 270? Negative 1.
Oh, so
See,
that don't work.
that's
that
the one
doesn't
that
work.
that's the one that caused the extraneous solution. So 270, go home. Not automatically. Nope. And it's not always the case that one would be eliminated either. So you got to check them. You don't know. I plug in 180. Cosine of 180 is negative 1 plus 1, and the sine of 180 is 0. Did that one work?
Yeah.
Yeah. So 90 and 180 are two answers. You're ready to do the first assignment.
The only time that we have to plug them back in is when we square both sides.
Yes. When you change the degree, possibly. When you change the degree from 1 to 2, you possibly added solutions you need to check.
But on the test, that's still like 3 out of 4 points, right?
Yeah, oh yeah, without a doubt. Like if you listen, yeah, this
That's
would exactly.
75%.
This would be
On one
4
question.
points. 4 points right here. If you didn't get rid of 270, that's 1 point off. Yep. Yeah.
It's fourth quarter. You can fine with that. Which is what I would say if I was a quitter, and I'm not a quitter.
You are
Mark
not.
my words, YouTube.
You were tough.
That's why he texted
You were
me. 'Cause
tough.
I ran a stop sign by our house. And he was like,
He texted
yeah,
you.
he was like, you're going pretty
Hey,
fast there.
everybody.
I said, are you sure that was me?
Thanks for the
and he
laughter.
said, yeah, Rosa said it was.
That's funny.
Which the one I handed out yesterday?
Yeah.
That one, everybody. It's due Monday. Everybody.
Do you have, like, so I can grade some of them?